Hi, I'm Kim Shepard. This is Blackboard Video 1C. We'll pick up where we left off with the last one. Last time you recall we talked about the who and the what being the most important features to understand about a data set. The who are the things that you're collecting data on, the what are the variables, but it's also important to be aware of when and where the data were collected. As well as how it was collected and why it was collected. So with any problem, you should be able to identify all 6 of those. For when the data was collected, if the data was collected years ago, now it could be very irrelevant. Make sure I spell this word right. And if the data was collected unscrupulously, our conclusions will be biased. So we'll talk in later chapters about some valid ways to collect data and some not so valid ways to collect data. So we do want to be careful about bias when we collect data. So here we have an example. This is from Professor Koop's financial transactions that are recorded on mint.com. And so you see here that we've got each one of his transactions. We've got the date, the description, what the purchase was, a category, was it a grocery purchase, a restaurant, and then the amount. So for this spreadsheet of information, let's identify the who and the what. So recall that the who, or the individuals or the cases, are typically in each row. And that's what you're collecting data on. And you can see that each row here contains a different transaction. So each transaction is the who. Squeeze that there. And then the what we see in the columns, these are the variables of the data. And so there are 4 variables in this data set. I'll let you write them down. But the 4 variables, or the 4 whats, are the date. So this is one. The description, the category, as well as the amount. So we've got 4 whats, or 4 variables with this one. For each variable that you have, we often want to try to classify what type of variable that is. You notice that some of these are words, more descriptive, and the final one here is an amount, is a monetary value. And so once we've identified the variables, we notice that some variables are numbers, like the amount, and some variables are words. And so there were several there, but one example would be the category of the purchase. Was it a grocery store purchase, a restaurant purchase? So some are numbers, like the amount, and some of the variables are words, like category was. The variables that are numbers, that you're also able to form mathematical operations on, we call these quantitative variables. And quantitative variables, it's not just that they're a number. They're a number, and you can perform mathematical operations with those values. So ask yourself this question. If you took the average, would the result make sense? Could we find out what the average amount was that got charged in each of those transactions? So does it make sense to compute the average transaction amount? Certainly does. So amount is quantitative. I'll throw this in here even though it's not here. Something that, perhaps I don't understand if it's a number. Give me an example of something I wouldn't be able to take the average of. If we looked at, say, your zip code's a number, but we would never say the average zip code in the class is this number. That wouldn't make any sense. So even though zip code is something that's a number, it's not a quantitative variable. Okay, categorical variables are usually words, but they could be numbers like zip code. These are variables that classify an individual, so we call these categorical. The category variable in the transaction example is categorical. Some transactions were called groceries, other were clothing, some were called restaurants. So these are categories for each one of those transactions. Zip code, even though it's a number, would be another example that's categorical. Your zip code identifies what town you live in, classifies where you live. So we've got quantitative variables that are numeric, and you can perform numeric operations with those. And we have categorical variables that are often non-numeric, but they're variables that classify individuals. If they are numbers, they're ones that just, where the number is not, helps to classify something. All right, let's look at an example. We have a data table where we're going to show you the first 4 rows of the data set. The data set actually has over 1,700 rows in it. This is for homes that were sold a few years ago in upstate New York, recorded by a real estate agency trying to predict selling price based on a house's characteristic. And for each one of the variables, we'll identify whether the variable is quantitative or categorical. Okay, so you can see here that we've got the first 4 homes. So each home is the who. We've got several variables, several whats here. And for each of our variables, we want to try to identify if the variable is a quantitative variable or a categorical variable. I'll place a Q here for quantitative or a C for categorical. You can even pause the video and try to fill this in and then check yourself to see if you have this correct. So price is a number. This is how much the home is selling for. Obviously, we could figure out the average price. So this is a quantitative variable. Lot size is the size of the property in acres. Again, you could figure out the average lot size. So this is also quantitative. Waterfront says whether or not the property was on the waterfront or not. This just classifies that house. It's not a numerical variable. This one would be categorical. Age is the age of the home in years. Again, we could figure out the average age of the homes in a data set, so this is quantitative. Heat type is the heating source for the house. This again would be a categorical variable. Living area is measured in square footage, and you could figure out the average square footage of the homes in this data set, so this one's quantitative. Bedrooms, number of bedrooms. Again, that's a value that we could compute an average of. This was quantitative. Neighborhood. Neighborhood is a number that each neighborhood was numbered. You know, if they lived in Sunny Hills, it was neighborhood 1. If they lived somewhere else, it was neighborhood, say, 5. You really wouldn't compute the average neighborhood. This just sort of identifies where the home is, classifies where the home is. So even though this one's a number, this is not quantitative. This would be a categorical variable. Bathrooms is the number of bathrooms. You could figure out the average number of bathrooms. That's going to be quantitative. And then finally, central air. Does the home have central air conditioning or not? That one would be categorical. So hopefully you did well with those. Finally, some variables we can think of as identifier variables. Some of the categorical variables are more like identifiers. Something like your student ID number at the college. Something you'd never compute an average of. It is a number. You don't calculate the mean. We would never make a graph of everyone's student ID number. And we don't analyze them. It's just that number goes with you. So this would be an example of an identifier variable. This identifies you as a particular Cecil student. In the housing example, homes listed for sale have an MLS number, a multiple listing service number, so that it's kind of like the VIN number on your car, so that realtors can access that property information from different computer systems. We would never really analyze that variable. This is an example of one that's an identifier variable. So this is an example of a home listing, and if we look over here, here's this MLS number, and any real estate agent from any company could access that number, and they would know that that number identifies that it's this particular home that's for sale. So that would be the identifier variable in this particular example. Okay, in the sports example that we had before from the fantasy draft, the identifier variable in this one would be each player. The player name here identifies what that row of information is about. So person's name would be the identifier variable in this one. All the rest of them from here on would be quantitative variables, I believe. In the Mint.com example with the financial transactions, the identifier variable in this one would be each description. Each one of these identifies a different transaction here and exactly where it was and what it was for. So that would be the identifier variable in this particular data set. All right, let's look at, I think this is the last one. In our Stat 2 course, students ran internet speed tests online using 3 different web browsers. They used ping, download speed, and upload speed were measured, recorded for 20 computers in the classroom. And here you have the first couple of rows of the information that was recorded. This is actually straight from StatCrunch, so you can see how this looks very much just like a spreadsheet of data. So in here, let's identify which variables are quantitative, which are categorical, and which are identifiers. So the who would be each item in each row. The variables here that we want to classify are the browser that was used, the computer, the row, ping, download, and upload. I think I have room to write more on the next slide. Here we go. Okay, so how about the quantitative variables? Let's start with those. If we look at for quantitative variables, computer identifies which computer it was. We would not compute the average computer. So even though that's a number, that's simply identifying there. That's not a quantitative variable. Row is the actual physical row in the classroom that the computer was in. We wouldn't compute the average row, so that's not quantitative either. Ping, though, that measures the speed of the internet speed, excuse me. So that would be one. We could compute the average speed. We could compute the average download time as well as the average upload time. So the last 3 here are our quantitative variables. Ping, download, and upload. All right, how about categorical? Categorical, we've got which browser was used. That's a categorical variable. The computer you could think of as a categorical variable, and same thing with row. They're identifying there. Where we were. As far as an identifier variables, again, are sort of a subgroup of the categorical variables. The variable here that identifies where we were is computer. That identifies which computer we were on when we did the testing. So I have it up there as categorical, but this is also the identifier variable for this problem. Okay, and I believe that that's the end of this video.